Hey everyone, we're going to continue solving systems of equations with different types of solutions. So in the task before this, we were solving systems using graphing and seeing the different types of solutions. So when we saw lines that cross each other, they have exactly one solution. We saw lines that sit right next to each other that are parallel that have no solution. And we saw lines that fall on top of one another with infinite many solutions. Now we can also have this when we're solving algebraically, right? So for exactly one solution, we're going to have x equals a number, y equals a number, which is what we've done in the prior. So you could also have systems end up being 4 equal 5. Now we know that 4 does not equal 5, not possible. All right, so those are the types of solutions you can, they could look like 2 equals 3, negative 4 equals 2. So that's going to be examples of no solutions. Now you also may solve algebraically and find that 5 equals 5. That would be infinite many solutions. So that's going to be the sign for that. So I'm going to show you 2 examples that I thought were the harder ones, and we're going to solve. So just like we solved in substitution, we want to get one of the variables alone. So in this case, it's right here, right? So y equals 2x plus 6. So that means every time I see a y, I'm going to input 2x plus 6. So let's write that out. Okay, so I'm going to rewrite the equation. And now that I see a y, I'm going to put 2 times 2x plus 6 equals, and I'm going to write the rest of the equation. Okay, and now I'm going to distribute. I'm going to do 2 times 2, I'm going to do 2 times 6, and I'm going to get, let's see if I can go back in here. So 2 times 2 is 4x, and then 2 times 6 is 8 equals 4x plus 6. All right, so now we're going to continue. Oops, I wrote 2. All right, now we're going to continue to solve. So usually we want to move our x values first. So I'm going to subtract 4x on both sides. And what you're going to see happen here is they're going to cancel out. Right, so 4 minus 4x and then 4 minus 4x. So what's going to end up happening is you're going to be left with 8 equals 6. Now I spoke about this before. So when we see something like this means no solution because 8 cannot equal 6. So it's going to be no solution, and here's the symbol for it. It's going to be no solution, right? So when your variables cancel out, you need them, but they cancel out. You're going to be left with 8 equals 6 in this equation, which means it's no solution. Okay, so I'm going to show you one more. We'll go to this one. So when we're solving systems, we want to look for the equation that has a variable by itself, which is this guy right here. So every time I see y, I'm going to input this because y equals negative 2x plus 4. So I'm going to input that. All right, let's rewrite it. 7 times, I see a y here, so I'm going to put in negative 2x plus 4, and then I'm going to rewrite the rest of the equation, plus 28. Okay, I'm going to distribute my 7, and I'm going to get 7 times negative 2x is negative 14x, and then 7 times 4 is 28 equals negative 14x plus 28. Oh, look at that. I don't know if you guys can see. Negative 14x equals negative 14x plus 28. Well, negative, yeah. They're exactly the same on either side. So this is going to be a sign that it's going to be infinite many solutions, right? And here's my infinity symbol. So here's me. You don't even have to solve anymore. We know this is infinite many solutions, all right? So I took these 2 equations because I thought they were the harder ones. So let me know if you have any questions, and good luck.